Hey there! Let's talk about radical expressions. So this is the square root of 4, and the square root of 4 is 2. And why is that? Well, it's because we need to find out what two numbers make up this number. In this case is 4, and it would be 2 times 2. And we know that 2 times 2 is just 2 squared. And if it's a squared, we can take it out of the square root, because the square root is pretty much the root of the square. And because of this reciprocal identity, so 2 squared equals 4, which means that the square root of 4 is 2. It's like the opposite version of the exponents, just like multiplication and division. So that's a little bit of an explanation of radicals, but those are perfect radicals. What if we had something like square root of 20? Well, we can break it up. We know some of the factors. Let's say we know 4 times 5. Well, that's not exactly a perfect square. Well, we can still break it up even further. We know the square root of 4 is just 2 times 2. So that's 2 times 2. And 5 cannot be reduced. So that's the furthest we can get. Well, we can group these two together and remove them. And if we remove them, we put them right outside the radical sign. So this would be 2 square root 5. And that's the furthest we can get with that. So let's try another one. So here we have square root of 72. And let's think about that. Well, we can deduce it that it has 2 at least. 2 times, let's say, 36. Well, let's break down 36. 36 is just 6 times 6, right? And that is 2 of the same number, so we can group them together and remove them. So we would get here 6 square root 2. And so let's try another. So when we have 2 square roots together, we have to multiply them together. So we have square root of 24 and square root of 54. If we multiply them together, we get this huge number that we don't really want to deal with. So let's take them apart individually. So we know 24 can be square roots of, let's say, 4 times 6, and 54 is just 9 times 6. So let's further reduce them. So 2 is just 2 times 2, so that's easily reducible. 6 is just a already simplified number. 9 is 3 and 3, and 6 is the same again. But wait, if we combine them together, that means they're sharing the same square roots, which means that we can actually combine the two 6's together too. So everything here works out perfectly. So let's group them all together, and outside they become, well, there's nothing in here, so 2 times 3 times 6, which is 36. We can apply the same concepts to variables as well. So let's say we have 32x to the 4th power. We don't know what number x is, but we do know that x to the 4th power is just simply x squared times x squared. So it's important that we know that exponents properties can apply here too. So we know that x squared times x squared, 32 is, let's say, 16 and 2, which works out because 16 is 4 and 4. So let's group these two and these two, and the 2 remains in the radical. So 4x squared square root 2, and it works out perfectly. Let's try one more. Another thing we can change is actually the radical sign too, the degree we're using. So instead of square root, we're making it a cube root, which means everything has to be in groups of 3, just like exponents. So this would be a cube root, and this is a cube radical. So let's kind of break these up into groups of 3 now. So 54 we know is 9 and 6. Well, let's think a little deeper here now then. 3, 3, and 6's, remember, 2 and 3. Well, we do have 3 groups of 3. So that's one of the things we can remove. Leave 2 behind. What about 6? Well, x squared 6, x to the power of 6, we can actually remove to be x squared, and x squared. So we can remove everything from that. It's pretty much just dividing it. And we can remove all of them. 3x squared and leave the 2 inside. But don't forget, we have to make sure we label it as a 3. And we can go higher up to 4th roots, 5th roots, x roots, and it goes on forever. Thank you for watching. This has been Simplifying Radical Expressions by SATFreepractice.com.